Welcome to the teardown episode of the Faber Castell tr2 calculator. The Faber Castell company was very known for its very good quality biro products like pencils and other stuff you typically will use in all the offices of the world. So they have made such pencils, but also they were famous for the sliding rule calculators, which looked like this. This is one of the most sophisticated models of such slide rulers, and this, what you see here, was the previous to the next era of electronics and calculators. It looked like this. Here you have the whole manual and the explanations what operations you can do with the slider rule. It has double-sided. It has a slider on the top and another slider in the middle, and with help of all the scales and precision mechanics you were able to calculate all sorts of stuff. But with electronics it becomes obsolete, and what this company Faber Castell did back about 40 years ago, they tried to keep on this market, and they brought to the market such a calculator series. It was advertised those days as the most thin calculator in the world, which I will show you in a minute, had on the back a slider rule in case your batteries run empty. This was such a battery block which slides in on the side and powers the calculator for several hours. The chip inside the calculator is not Faber Castell made, but it was bought in Japan and just, I think, assembled in Germany. This is the front appearance. Here the small window hides the display, which is microbubble display and LED display. I already loosened all the screws. Now I take those screws off. We put them aside. One problem with this calculator was the batteries doesn't last for very long, and as you can see on the outward appearance, they just invented something in a very fast manner. So the screws which assemble all the things are visible. They are black and sink down, but it's not so elegant design, I would say, not for this Faber Castell company. Beside the tr2 we have tr1 and tr3 with increasing grade of all the mathematical functions which were implemented inside the calculator chip. And the clue is on the back you have a slider rule which can replace the calculator in case the battery run low. As I said before, construction is the same. How to use the slider rule is a complete different story, and I won't bother in this video. We have 4 feet which are probably glued down to the case, and in the front we have one more screw. Yeah, thank you very much. Do I have the wrong screwdriver? No, it doesn't seem so. That must be the right screwdriver. I just need to fit the blade into the slot like this. Now we remove the last one. We scratch it a bit. It won't look as good anymore. And here we go. We have separated the calculator from the case, which just is a whole block, and the battery compartment here afterwards just slides over those both pads and makes contact. Let's put those aside for a while and let's concentrate on this part. So we do have one chip design. The chip is called A5502CA and the date is 1975 and week 39. I almost don't recognize the sign, but it could be, yeah, no, I don't know what the brand here is. Maybe you could see better. We will also unscrew the PCB from the plastic casing, but we have to keep in mind that all the keys which fell out when we do this. So we will try not to disturb all the keys. We have another 4, 5, 6, 7 screws. One of the screws is secured by red paint. I need another screwdriver for this job. This one is okay. Well, those calculators are very rare on eBay. You don't see any offerings very often, and is such a popular thing for all collectors and museums because it was on the border of two eras, of slider rule era and electronics era. As you can see on the layout, it is very old-fashioned, with all those traces probably drawn by hand. Maybe the engineers at Faber-Castell wasn't such experienced with all the upcoming new technology, but they did their job well and have accomplished something what is also referred to as changer calculator. So you have the possibility to use slider rule or the electronics. Now I loosened all the screws. Here's another one. It was one more. I didn't saw this one before. And this is how the calculator looks inside. First, let us talk a little bit about the front plate. Here are all the individual keys. All the keys are spring loaded, and the principle of operation is when you press the key down, the springs spread apart and make contact between those plates in the PCB. As I can see, the plates are not plated. This is probably just chrome, but not gold. I'm a little bit disappointed by that. They could have made something better than this. Oh, here is one which seems to be gold plated, but it is the metal on the key and not on the PCB. Also, the PCB has on this side no solder resist. Just here seems to have solder resist mask on it, and the chip is connected directly to the display, which is LED bubble display with 1, 2, 3, 4, 5, 6, 7, 8, 8.5 digits. The circuitry you see here on this side is needed to convert the battery voltage of about 6 volts. Here is like how the battery looks like. And the unbelievable thing is that the calculator still works with the original battery. I have also a charger for this battery, and I just removed all the gunk which has collected on the front and the bottom plate, and I charged it. It has almost 0 volts on it, and it charged it to about 6 volts and was still working. So the quality of the battery used here is outstanding. You won't meet such a quality in the modern devices you can buy today, like phones, tablets, notebooks, and so on. I was very surprised, and it even probably wasn't intended by the makers of this battery pack to last so long. Because, right, a calculator like this you will find today in every mobile smartphone, but it's a piece of history you hold in hands and can see. You probably can see behind the bubbles what is inside the microchips underneath, but every of those LED bubble displays has individual bond wires which connected to the plate underneath, and then to the outward connectors which goes down. No, it is directly, this is a double side PCB, and this display is directly soldered to this side by the means here of this connectors line. It then looks very good for the time that passes. This is most 76 it was made. Now we have 2015. That's a lot of time which passed, and obviously the calculator still works. We have 2 tantalus, 3 tantalus capacitors, and this must be something like a voltage converter. I'm not sure if this voltage converter is intended for the LEDs or for the chip which is on the other side. The old chips was made in the CMOS technology and needed 2 or 3 separated voltages, 2 positive voltages and 1 negative voltage, and maybe this power converter is intended for the chip and not for the display. I don't know exactly. So I think that's all what I can show you in this video. I hope you've learned something, or at least you find this video interesting. If you are a collector or just in general you like things about old vintage stuff and calculators. So thank you for watching, and maybe to the next time. Bye.